With that, without waiting any further, I want to jump right into the program. Our first disruption of the day, if you will, is the labor force disruption. And I couldn't be happier than I am to introduce Dr. Ben Armstrong of the MIT Industrial Performance Center, who will speak to that. And I think what you're going to see from Ben is not only a description of what's happened in the past year, but how that gets placed in context with a trend, a structural trend that's been building for many, many years. This is something we're all going to have to respond to, or we're just going to be in another world of hurt the next time this happens. Ben, please join us.
Thanks so much. Now, I got to put the pandemic metaphorically around my neck here for a few minutes. I still have little kids, so I'm wearing this as much as possible. Really, thank you for having me to ILP. I'm very excited to be part of this conference and take on some of these really important topics that are part of the agenda today. So as many of you have seen, and if you're practitioners in industry, you've lived it, over the past year, even more, there have been headline after headline, issue after issue with labor shortages and with many job openings, the idea that companies cannot fill the positions that they're advertising for. Now, I look at this as having a silver lining. So let me just walk you through some of the data that we have. You can see right here, and I have a nice pointer, that here's the beginning of the pandemic, this shock. The green line is job openings as a percentage of overall manufacturing jobs. The blue line are what we call job separation. So these are firings and layoffs. A lot of these are layoffs early in the pandemic. And then the red line here are wages, hourly wages for production and supervisory workers. This has changed over time, anchored in 2010. So what's happening here? What we see is that even before the pandemic, the share of job openings as a percentage of overall manufacturing jobs, even though manufacturing jobs go up 12% between 2010 and 2020, the share of job openings are getting higher and higher. Manufacturers want to hire. They have a lot of demand for manufacturing work. Business is very good for the manufacturers I work with and talk to. And the real challenge is that they can't hire fast enough. So I looked at it as good news, is that the business and the demand is there. One of the challenges and the kind of the big quit or the great resignation that many of us have heard about is actually not as significant in manufacturing as the demand, right? The ongoing resignations and quits are right there, maybe about 50%, 40% higher than pre-pandemic levels. But if we look at job openings, they're 3-4 times higher than pre-pandemic levels, right? So the real issue is job openings and demand for job openings. But what I want to focus on more today, because we have a clearer picture of it than just the pandemic story, is this growth in the green line right here. Between 2010 and 2019, we see more than doubling of job openings in manufacturing, this big demand that is unmet for new manufacturing workers. And company after company, I'm sure a lot are here in the room, say, we just can't find people to fill our needs. We can't find people with the skills we need to hire. So what's going on here? Just to share some data, this isn't just me, reporting a few anecdotal stories from interviews with companies. Over time, these are data from small and medium manufacturers when asked about the 3 biggest challenges in their business over time. And you can see right after the recession, and perhaps this isn't surprising, 2008, 2009, only about 20% of manufacturers when asked said that workforce issues were a top 3 concern of theirs. You can see as business gets better over time, this goes from 20% to 40%, and then up to 60% before the pandemic. This is one of the top issues that small and medium manufacturers talk about when they're asked to describe the challenges facing their business. It's also an issue for large manufacturers. Of course, in pandemic surveys, this is top of mind, but this is pre-pandemic data, where large manufacturers in a National Association of Manufacturers survey say that workforce retention, workforce attraction, that's the top issue of concern. So clearly, this is really important. We want to get into a little bit more of the difficulties. So why is it so hard? Why is this such a big deal? And this is something that I've talked to a lot of manufacturers about. I've tried to understand in the data what might be happening here. And I want to give kind of a big picture story and then go into the details of what I've learned along with some of my colleagues here at MIT. So the first part of the story is that for many decades, for more than 3 decades after World War II, there was a really high-performance equilibrium among U.S. manufacturers. Technology investment was going up, wages were going up, manufacturing careers were good, manufacturing businesses were competitive, they were innovating, they were exporting. And what's happened since the beginnings of trade competition in the early 80s, followed by the explosion of trade competition in the early 2000s with China's accession to the WTO, is that it's gone from a thriving equilibrium really to a surviving one. So a lot of manufacturers that I've talked to that are multi-generation businesses, many of them privately held, went into survival mode at somewhere between the 90s and the 2000s. And what happened, as some of you might have experienced firsthand, is that technology investment slowed, wage increases stopped, the career paths in manufacturing really looked less clear, and what we see in the data is a really striking kind of two-phase picture. So if you can look, so I'm plotting here, and if you have any questions about these graphs, I'm going to go through them relatively quickly. I can come back to them, or you can ask them in the middle. So I'm plotting here capital expenditures. These are for manufacturers as a whole in the US. Employment, so number of manufacturing jobs. Productivity, so value added per worker. Actual just raw value added, and then wages for production workers. And what we see that's, I think, very positive in the 40s to about 1980 is that all those lines are going up in parallel, right? Technology investment is going up pretty dramatically, value added is leading the way, but employment and wages are going up too. So there's this really positive feedback loop that's happening in US manufacturing for many decades. And you know, like I talked about in the survival mode, it looks quite different, right? Productivity continues to go up until about 2010. We haven't seen any productivity growth for the last decade, but we can talk about that in a separate time. So productivity growth goes up, but that productivity growth isn't driven by real advances in technology investment or real advances in exports or value added. It's only driven by the decline in employment, really surviving by cutting labor costs. And these lines are, you know, just show flat wages, flat capital expenditures, flat value added. Okay. So this is what we've been focused on when we're kind of focused on these big picture manufacturing questions at MIT for the last 40 years or so. I guess a little less if we're starting in '89. We've been trying to understand what are these big picture issues in manufacturing, what are the policy questions, and then what can we do about these issues to help resolve them. So beginning in '89, as the competition, this was largely from Japan in the 80s, but also kind of some competition and dysfunction internally in the United States. A team led by Richard Lester, who actually founded the Industrial Performance Center, of which I'm now a part, wrote a book called Made in America, which was trying to understand these challenges facing US manufacturing in the 80s. Many of the conclusions in that book, which I turn back to now and then, are still very relevant, and we never really learned the lessons of the challenges in the 1980s. So a lot of what I'm going to talk about today and what I hear from manufacturers today isn't really new. These are some of the same things that manufacturers were saying more than 30 years ago, around when I was born. The second wave of these questions came in a very different manufacturing environment around 2010, right after the Great Recession, when a group at MIT led by Suzanne Berger asked the question in a world of globalized production networks and American companies having most of their production abroad. It's like, do we actually need American production for more than small batches? Is this actually important to the economy? What are we getting from producing in the US? And what the production and innovation economy study found, which I found really interesting reading it for the first time, was that we don't necessarily just need production for good jobs, for middle class careers. I mean, one of the concerns that many people have is the loss of manufacturing jobs has been associated with the decline of industrial communities in the Rust Belt, where I'm from. But it's also the loss of innovation, that one of the benefits of producing domestically, of having local domestic manufacturing capacity, is that the companies engineering and designing products can be close to seeing the products come off the line. And that there's an iterative benefit of working closely with domestic manufacturers to understand and improve your production process. It's much easier, for example, than an Apple engineer going to a Foxconn factory and trying to figure out, maybe going over for 3 months out of the year and trying to iterate from there. So that was one of the main findings out of production and the innovation economy. Just to accelerate ahead to the present day, we're coming out of a project on how technology is transforming work, which informs some of the findings in my own research. And then we're about to launch this new project, which I'm happy to talk more about if any of you are interested in. And that's a multidisciplinary effort between mechanical engineers, aero-astro, myself as a social scientist, understanding, given the advanced technologies that we have available and that we develop at MIT, what could we produce competitively in the United States? What could we export today, and where should we focus in industrial policy? That's the focus of our ongoing research. Okay. So now let's get into some of the details behind this survival mode of US manufacturers and the workforce challenges they're facing. So when I talk to US manufacturers as part of my own work, I do some data work, but I also go out and talk to various firms. Many of them are small and medium firms. Of course, 98% of US manufacturers have fewer than 500 employees. That's the bulk of the companies I talk to. So my findings will be a little bit skewed toward that experience. But I hear three things over and over and over again. And the first one is that all my production workers, who are the highest value, not all, but a large share, are old and they're retiring. And there's a fear that when these workers retire, these companies won't know what to do. They're so reliant on workers over 55 who have very tailored machining skills, welding skills, they're tool and die makers, and they don't see the same skills coming into the workforce that they can train. And it takes a really long time for these companies to invest in these workers to replace the retiring workforce. So here's just a little bit of the data behind it. This is a manufacturing institute, which is, I think, sponsored by the National Association of Manufacturers, showing that there's a high share of these older workers in a lot of manufacturing companies. And I don't think this is going to be surprising to many of you in the audience, that there's a graying manufacturing workforce. The second thing that I've heard over and over, which I was surprised by actually, is that these manufacturing companies said they hire for will and they train for skill. The common perception, at least from policymakers I talk to, is that there's a skills gap in manufacturing. And what they think that means is that manufacturers have advanced really far ahead in their technologies, but workers don't really know the technologies that manufacturers have because it's so advanced. So what community colleges, for example, need is more courses for robotics technicians or dealing with laser welding, that type of thing. So what we have now are in some community colleges, very advanced laboratory equipment, very high technology settings that don't really match the need of a lot of small and medium manufacturers. So small and medium manufacturers I talk to, I don't need another person to program a CNC or to operate a robot. I don't have any robots. What I need is someone who can operate a machine and has an ear to understand when the part's being cut wrong. And that type of demand that these companies have suggests that they need to actually hire people who are motivated and trainable, not necessarily for particular skills, because they're focused on delivering those skills internally. And here's a little bit about, just a little graphic on what that means. So in any worker, how we model it in the social sciences is it's going to take general skills that you might get in high school, let's say, of how do you read something to understand it critically, how can you write to communicate to others, doing basic maths, algebra, some calculus. And then there are some industry-specific skills that you might need to actually operate on a factory floor. You might get those, some community colleges or vocational schools might offer those. And then you're going to have firm-specific skills, the standards and procedures, et cetera, et cetera. Now, what the hope would be, and this is what happens in, let's say, Germany and Switzerland and other cases that have a developed vocational training system, is that there's an educational institution, some place where you could go to get at least a good share of those industry-specific skills as well as your general skills. But what we have right now in practice in the United States is that the educational institutions are really only providing the general skills, and then companies are taking on both those industry-specific and the firm-specific skills in terms of on-the-job training. When I talk to companies, I ask them, how long does it typically take you to have someone who walks in the door, motivated, ready to learn, to being fully self-sufficient on the job? They say about 1 to 3 years. And it's really expensive to train that person 1 to 3 years because you're paying them a wage. So it's essentially subsidized training plus a wage that has to be competitive down the road with Amazon. right? So this is the more and more during the pandemic. What I've heard is that retailers like Costco that are raising their minimum wage to $17, similarly Target at other levels, Amazon around $20 in the local markets, that companies are just losing their younger workers who might be motivated to these higher wages in jobs that might actually have more flexibility and be easier in some ways than working on a factory floor. So one of the struggles I think a lot of companies are facing is how do we compete with Amazon if we can't, just according to our business model, offer a $20 to $25 an hour starting wage for someone out of high school or community college. Okay, so if we summarize quickly that the workforce model that really thrived for a long time with manufacturers, particularly small, medium manufacturers, was that you come to work, and this is a place you can build a career over 20, 25 years. You'll build skills, it'll be rewarding, you'll be trained, and we'll invest in you, but the return is going to be high for the manufacturer and for the worker who's going to retire with a pension with a lot of benefits. But that model has been a bit thrown on its head because we're in a higher turnover environment now. The risk of training is that you're going to lose an employee to a competitor down the road or to Amazon, so that this training investment might lead you to question it a little more. And technological paradigms are changing. So there's this real question as the graying manufacturing workforce. Do I bring someone in to be a welder and a tool and die maker with the same skills as the person who's retiring? Or do I rethink my process, invest in technology so that I now require different skills? And that's what I want to talk about a little bit, is the relationship between that technology investment piece and the workforce skills piece. So, what I've just described, those three, the hire for will, train for skill, graying workforce, that describes about 85% of the companies I talk to. But there's this 15% of companies, and when I talk to them about workforce challenges, they say, well, we don't really have those challenges here. We're able to recruit the workers we need. We don't run into hiring difficulties. We're able to fill our job openings. And this is always kind of gets my ears to perk up. So, okay, so what's going on in your shop? What's different in your shop than in others? And one thing that I find strikingly different is that these shops are typically higher technology places. There's some startup element too, where there's an exciting, manufacturing startups have an easier time recruiting good production talent. But a lot of the companies that have invested in new equipment, I'm going to use robots as an example, have an easier time recruiting and retaining workers. So there's a really good paper. This is pre-pandemic data, but still I think it applies. And there are a few papers from Europe as well that show companies that have adopted robots end up being just more competitive. It might not be the robot. It might be that companies that are more competitive are more likely to adopt those robots. But they also the workers have higher wages. And they pretty much have better outcomes for labor and for the firm as a whole. So there's really an association here between technology adoption in the manufacturing context and worker outcomes. Of course, there's also work from MIT that shows in places where robot adoption is high, overall employment's declining. But when you dig down into those data, it looks like the losers of robot adoption, really the companies that lose out, are the ones that don't adopt and end up struggling to compete. So why might this be? Why do you have it such that when you adopt a new piece of equipment or new technologies, why are you thriving? Is it just the productivity benefits of the piece of machinery itself, or is it something broader? What we found through interviews with companies after they adopt these pieces of equipment, what they say is that it's not just the equipment, it's that the equipment forces the company to rethink and redesign their processes and retrain their workers. So even if they hadn't been investing in training before adopting the equipment, now they adopt the equipment, and typically they buy some training from either the technology provider or a third party along with it. So this kind of moment after you adopt the technology is a real opportunity to improve training and upskill existing workers. We don't really have any cases of companies saying kind of goodbye to existing workers, laying off existing workers and bringing in new workers to operate the equipment. It's almost always upskilling existing workers. The second piece here is training partnerships. There are some companies that I like. There's an example from Ohio that I really like. There's a group of companies in Northeast Ohio called the Alliance for Working Together. And what they found was that many of the companies were facing some of the same skills challenges that I've described or are widespread among small and medium manufacturers. And they said, well, we just don't want to deal with this anymore. We need more skills among our workforce. We need to motivate people to enter manufacturing. So they started by creating a high school technology competition. Essentially, it was a robots competition to teach people about manufacturing, help them build things, and essentially inspire the smart students in high school to get into manufacturing. And the program was a big hit. Kids loved it. But it ended up that all the best performers in this competition went off to elite colleges and didn't come back to Northeast Ohio to join these small, medium manufacturers. Like, okay, well, that was a success, but it didn't quite work. So let's try something else. So the companies then banded together, some of these companies, to start a joint apprenticeship program. And what they realized was, unlike large companies that might be able to have a one-to-one partnership with a community college where they can offer a pipeline to hire 5, 10 students a year out of a community college, these small, medium companies can't do that. They can't essentially demand a tailored curriculum because they're going to promise to hire. But what they could do if they banded together was pool their resources to identify some specific skills that were common across these companies and then train for those skills. So what they did, instead of partnering with a community college, they've done that since then, but they had volunteers, senior folks at each of these companies, volunteer to train workers from across the companies, a pool of 24 or so workers. They have multiple cohorts in this program now. Train them in advanced technologies for manufacturing. So now the workers are not only learning these advanced technologies, they're also learning about the environments and the skills that their peers at other companies in the region have to have. So it's bringing new knowledge and new ideas into the companies in this community. So I find that to be a really innovative model that's almost like a grassroots version of a more what you might see as a more formal apprenticeship program in other places. And then finally, I've been doing some work on wages. Now, one of the graphics at the beginning had this flat line for wages. There has been some increase in wages in U.S. manufacturing since this shortage. Adjusted for inflation, it's really not much, but there's been some increase, a couple of dollars for median production wages. But the question is, where should we invest? Should we invest in raising the floor of manufacturing wages? Should we invest in kind of a better broad-based career for, let's say, machinists or operators? From conversations with these companies and looking at the data, I think we should invest in a more targeted way. And we should invest in the highest performing folks on the shop floor, the folks who are trusted to integrate new technologies, to re-engineer processes when a company is developing a new product. And over and over again, I talk to companies and I ask them about, how did you adopt this new technology? How did you make this new product? And they're saying, like, oh, it was Jim. Jim did it. Or it was Jim and Sarah. A couple people who are really trusted to be creative in this process, people with typically only a high school education. Maybe they've gone to a couple years of community college. And we've started calling these people shop floor entrepreneurs. And they have this outsized impact on the status of the company, on the outcomes of the company. And there are no real resources for these people. They figure it out by their own kind of creativity and force of will. So what we've proposed and what we're trying to work with policymakers on are more specific training options for people like this. So they don't just have to watch YouTube videos to figure out how to make a technology work. So they can perform even higher given their motivation and creativity. And just to give you some data, so these I call them shop floor entrepreneurs, but really what they are non-degreed engineers, people who are high school graduates who end up being considered an engineer within their company. And if we look at this is just a box plot with different manufacturing professions. But what's striking to me is that there are 3 tiers of manufacturing professions. So there are kind of the machinists, kind of operators, tool setters who are lower wage. So if you look at the bottom of the box, that's kind of approximately what we would think of as an entry-level wage. So maybe $17, $18. Your mid-career, you're making $22, $25. But for a non-degreed engineer, it's totally a different game. That at the end of your career, you might be making $40, $50 an hour, 80, 90K a year, and that in the red box, these are high school graduates. It's just a much better wage than you could make almost in any other production occupation as a high school graduate. So right now, it's 17% of the engineering workforce in manufacturing does not have a college degree. So it's currently, I would say, an unrecognized but pretty large population of people, and it's a population I really think we need to invest more in developing their skills. So to leave with, I think, some good news, a promising path for the characteristics of companies that have either avoided or preempted some of these workforce challenges. I think there's really a link between technology, training partnerships, and then finally investing in the, I would say, highest value add members of a manufacturing team. Thank you very much. I'm happy to take any questions.
It's on? Yeah. I was actually feeding a question into Pigeonhole for you, but I'm just going to ask it myself to start with. You mentioned the high school robotics competition in Ohio, and that touched on a personal experience I've had as well. It's easy to buy the robots and start the competition, but the motivated kids will always find that, and the ones you want to reach won't. Is there a policy solution in education and educational curriculum that could also maybe help to get the pipeline flowing for these kinds of jobs that you talked about?
It's a question that at MIT, Paul Osterman is someone at Sloan who I don't know if some of you might know, who's done a lot of work on adult skill development and adult education. So what types of policies or programs might you create in order to ensure that adults can advance throughout their careers? And what Paul's found, I think, through a lot of his work is that it's very hard, and that we've had a lot of failed attempts to do skill development for people that aren't at the top of the distribution, like you're talking about, the motivated people. There's some promising data that's just come out on what are called sector partnerships or sector-specific skill development. So a lot of IT partnerships. There's this program called Perscolis that does a really good job. Hasn't really translated into manufacturing. There are some MIT experiments going on that I think have preliminarily positive results. There's some programs in photonics, for example, very focused with very specific employers. In a group here, there's partnership with Stonehill College. But we don't have a lot of great evidence, unfortunately, for kind of the training or improving outcomes for the meat of the distribution. And that's the tough trade-off. When I talk about investing in shop floor entrepreneurs, it's unfortunately, I think, at the expense of investing in the training of the masses. And I think just talking to employers, it's this question of, okay, do I try to get the most out of the workers who are super motivated and who I really want to retain, or do I focus on the workers for whom I don't really know whether there is a solution, and the investment per person might be untenable for a small company?
Great. It seems like we're trying to get some other questions up and running, and while we do that, I will actually ask another one, because you focus a lot on the United States, and that's certainly where the studies that you referred to have been the most focused. Today, as we go through this, we're going to talk about issues associated with globalization, global supply chains, global geopolitical disruptions, and things like that. How does what you're recommending for U.S. manufacturing embed itself into what's more a globally connected economy? And will probably stay that way.
Yeah, so my research focuses on the United States. I certainly look at U.S. issues in a comparative context, but if I'm looking at, for example, Japanese manufacturing context or South Korean manufacturing context where technology adoption is really high, I'm personally focused on how do we draw lessons from excellent technology adoption in those places to bring them back to American manufacturers. In terms of global supply chains, one interesting question during the pandemic was, was there really an opportunity during the pandemic to reshore certain products or to shift the architecture of global supply chains? And I'm pretty skeptical of that, even though there are boosters of reshoring who looked at the pandemic and said, we gained 10% domestically. The resiliency of global supply chains during the pandemic, I find just extraordinary. Looking at trade data and how quickly the volumes of trade bounced back after that additional dip, particularly when a lot of countries that are major exporters to the United States were dealing with their own supply crunches. It was it was a matter of 2 months before we reached pre-pandemic levels, and I just am kind of baffled by the power of global supply chains after that. But it's not my area of expertise, unfortunately.
Well, we will definitely cover that later in the conference. If we don't have any more questions from the audience, that's great.
Okay.
Oh, we do, okay. This is exciting because I've been tap dancing.
So I'd love this software question. So this is a real current area that we're studying, and we don't have good answers yet. And despite not having good answers, I'll say something more about it. But we're working on a project right now to understand the landscape of software adoption. We have pretty good data on hardware adoption across manufacturers of different sizes. We don't have good data on software adoption. What we do know is that even at large manufacturers, there is unlikely to be a dedicated senior level software team. So investment in like firm-specific software skills has been low, and what that means is that a lot of manufacturers end up relying on third-party off-the-shelf solutions they can't customize in the way that Amazon has done, for example. So trying to understand whether there is a more customized road for manufacturers that do invest in software skills, I think is really exciting, and hopefully by this time next year, we'll have a much better answer to the software question. But we're trying to figure out why software adoption has been, at least customized software adoption has been so low, and that companies are getting so little out of the data they collect. Because a lot of companies are starting to collect this really valuable data, but they don't really know what to do with it. Okay, so $20 an hour, which is not high. Labor costs are much higher than many other countries. How do U.S. manufacturers compete? I think that's a straight technology answer, is that the reasons. I mean, I don't. Maybe there are folks, who operate in the EU who are here. But one of the reasons why the production wages in Germany can be much higher than the production wages in the United States. I mean, there is labor organization and there is this process of co-determination. But they're also that they're more productive, and they're able to be more productive in part due to technology investments and investments in process engineering that I think surpass many U.S. manufacturers. And when you look at more productive even U.S. firms, they can afford to pay workers a lot more. I'll give one example that. A firm that adopted a robot, the main wage they can offer for an operator pre-robot was $40K, and then after adopting the robot, the same worker who had been trained for new skills could make $60K, right? So it's a 50% jump for the type of operator company with 20 people. It's pretty good in terms of wage outcomes in those cases. Shop floor entrepreneur. I think it's, I love the question. I don't feel equipped to answer how companies identify newer employees. I'm always excited to talk to HR personnel who treat their jobs almost as career counseling. And I find those leaders within companies really valuable. I talked to an HR, kind of VP of HR recently, who was talking about how a lot of her day is troubleshooting employees' problems about why they can't get to work, the family issues they're having, and trying to find that motivation, that potential within each of the people. So I feel like that strategy of getting to know the people, investing a lot in HR, having dedicated HR staff is exciting. What's wrong with YouTube? Nothing's wrong with YouTube videos, but I do feel like something more systematic might be helpful as well. Someone to walk you through the YouTube video, maybe to have some kind of in situ equipment that you're working with would be good. All right. One more. I'm going to pick this one even if it wasn't upvoted. So. Okay, productivity declines, my favorite topic. What are the root causes of productivity declines over the last 10 years? So I think it's pretty shocking that U.S. manufacturing productivity has gone down since 2010. One reason is that the way we measure productivity, employees are on the denominator. We've actually had manufacturing employment go up by 12%. So what that means, for productivity to go up, we'd have to increase our value add by more than 12%. The problem is our value add hasn't gone up. So why is that the case? I think if you break it down by industry, you see certain industries doing really well. They're becoming more productive. They're investing a lot in new technology. Aerospace, despite the past few years and the challenge, aerospace has done really well. Chemical and chemical-related industries, like medical industries, have done really well. But auto, for example, just value add in auto has been really bad since NAFTA. And this was a huge chunk, a real concentration of manufacturing expertise, particularly in the Midwest. But if you look at the share of value add in U.S. auto, it's gone down, 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 and really been a lower share of overall value of the car that we're making in the U.S. What's the antidote to that? It's Tesla. So I can leave it there with a little provocative note about Tesla.